All right, welcome back, everybody. So we've built this spreadsheet for you, but I want to show you a little bit about how that process actually happened so you feel like you know a little bit of the behind the scene details before we go and try to edit things. So the first thing that I did for Riepma Cottage is enter in some of just the basic information here. So the address, the home conditioned area, that's just the number of square feet that currently exist in the home. Then I went down and started to add some information about the different spaces, the different types of spaces in the home. So Riepma has two different sections of attic. There's one attic, if you remember the video, that has about R19 insulation, blown cellulose, and then there's a second part of the attic that's above the main ceiling of the home. I'm also looking here at the first floor. In Riepma Cottage, I'm looking at the first floor and not the basement walls necessarily because the first floor is above that unconditioned basement space. So I'm entering in the size and areas of all of these spaces. Next, moving on to the doors and windows, we have three different exterior doors. We have door 1 and door 2, which are on the outside, front door, back door. And then door 3, which is this weird door in the attic. We have a bunch of windows. What I've done here, this 126 square feet, that's just adding up the areas of these double pane windows. Next, what I'm doing is going to the exterior walls, and I'm actually going to click on this. If I click on this formula, you can see a number of cells light up. I'm actually calculating this from 944 square feet, so that is the exterior first floor walls. But then I have to subtract off the fact that we already are considering windows and doors. So door 1 and door 2, that's the pink and red here, or purple and red, those are already being considered. So you can see here in my equation in cell C26 and 27 are being subtracted from that 944. And then I'm subtracting off half of our windows, kind of assuming half of the windows are on the first floor and half on the second floor. So that's my equation there. Here on the second floor, similar. So we have a little bit smaller square footage, initially 680 square feet. And then we're subtracting off the windows as well as our door. The basement exterior wall, so the basement is a little bit shorter than that first floor, so I'm finding the basement exterior walls, and then the rim joist, which is 8 inches high, or 1/12 the height of the first floor. So I'm adding that in as well. That sits down below, so we're getting about 79 square feet of rim joist area. The last thing I need is average ceiling height. So I've entered in an average ceiling height of 8 feet, which helps me to figure out down here in gray, you can see the ceiling height times way up here, the square footage. That gives me the amount of air that I have in the room. That's going to be really key for calculating how much air is actually leaking into the space and how much heat that's taking. So once I have kind of the basic dimensions laid in, then I have to enter in some construction information. So I'm going to first enter in the existing insulation here into the pink area. So we have R19 insulation in the first attic space and R11 insulation in attic 2. Again, attic 2 is the part above sort of the living space of the second floor. There's no insulation beneath the first floor. Our existing doors do provide some insulation value, as do our double pane windows. And then we have existing R7 insulation in the exterior walls. No existing insulation in the basement walls, and no existing insulation on the rim joists. So this gives us our initial setup. In here, in the wall area, you can see, I'll just choose this cell. You can see this is actually an equation. The insulation value is not only the wall, it's actually all parts of the wall construction. So it's the insulation value here, E22, this blue cell, 19. but it's also 0.7. So if I look at what that is 1/2-inch thick drywall. So my ceiling is composed of drywall, and then above that is the insulation. When I'm talking about the total heat transfer, I have to consider both of those, the insulation, but also the rest of the wall construction. So I've done that throughout. Maybe one more that I can click on is the exterior, because that gets kind of interesting. We have the insulation piece of the exterior, but we also have other aspects of it too. So we have drywall, vinyl siding, as well as the wood sheeting on the exterior. So those all get considered as part of the full wall construction of the building. Right? R values are additive, so my equations are typically pretty simple. So I can do that throughout. Once I have that construction information set, now I have to set the air changes per hour. So this baseline value is an estimate that's taken from past energy use, other analysis of old homes, and really estimated to try to get a reasonably good picture of the home as it exists today. It's something that we're going to have to change and tweak and try to do our best job estimating for each individual property based on the information and kind of audit information that we have for that property. Once we've done that, again, in the notes section, I have some information about what I'm actually considering in each of these different spaces. But once we've done that, we have our baseline system set up. You can see this, there are a few other columns. This R manufacturer total includes even a little bit more information. So there's the wall construction, which is here in column F. Column G includes things like convection. So the heat is in the air. Convection is the process where the heat moves from, say, the center of the room actually up to the wall. So it's like the breeze in the air, right? So we need to consider that as well. Then here, this column Q is set up similarly across all of these cells. It's right, Q equals area times the temperature difference divided by the R value. So the temperature difference, the inside to outside temperature difference, in certain spaces I've made some judgment calls where, for example, the attic, because heat rises, I'm actually kind of bumping up the temperature difference a little bit here to try to get a little bit better picture of what that looks like. In other spaces, I'm looking at differences, for example, in convection. So I have the inside and the outside, maybe something the inside and the basement. Once I find these Q values to change to therms per month, it's a fairly straightforward unit conversion. And then the last piece I'm doing is using some properties of air and my air leakage. So this is air leakage as well as the properties of air and the temperatures to try to get the total heat from this air changes per hour process. Then my total amount of heating is just the sum of all of those columns. So you can see I've just added up all of these columns, and that's what gets into Q total. All right, so hopefully you have at least a basic understanding of how this spreadsheet works and how it's built. What we're going to do next is see what we need to do, what you guys need to do to actually simulate some project happening. So join me in the next video and we'll talk about that.